Hi everyone, welcome to Cultrep. So the numericals that decides your score. So let us solve some numericals on three-phase circuits, right? So now let me take the first problem here. So the line A to neutral voltage has given, which is VAN. VAN has given this problem, which is equal to 10 at an angle of 15 degrees. So what we need to find? The voltage of line B with respect to C. So either by vector diagram we can find, or we can find from the fundamentals also. So for example, if I take VAN as a reference, that is V phase at an angle 0. So what is VAB? So VAB is line voltage, so which is root 3 times of the phase voltage, root 3 times of the phase voltage, and at an angle of plus 30 degrees. The line voltage leads phase voltage at an angle 30 degrees. But it was, the reference is somewhere. So the reference is like this. And VAN is like this. VAN is at an angle 15 degrees. Now what we need to do? So if I want to find the VAB here VAB, so which is equal to 10 root 3 at an angle of, so 30 plus 15, 45 degrees. 45 degrees. So now, if I want to find the VBC, how we can find? So VBC is the 120 degrees out of phase with the VAB. So that is root 3 into V phase at an angle of minus 90. For example, if I want to find here, so VBC equal to 10 root 3 at an angle of minus 90 plus 15, so which is minus 75 degrees. For example, if I want to find the VCA, so that is, as we know that root 3 into V phase into, so 120 plus 30, it is 150 degrees. So if I want to find here, VCA, so 10 root 3 at an angle of 150 plus 15 degrees, so it is 165 degrees. So now the answer is 10 root 3 at an angle of minus 75 degrees. So this is how you can find for the different line voltage. So it is option C is the right option. So now let us solve the next question. So here it is asked in the civil services. So in a symmetrical three-phase system, the phase sequence is given as R by B. So what they have given? A capacitive reactance 10 ohms is connected across YB. So now the phase sequence, let me mark the phase sequence first. It is R by B. So and what is the problem? In between Y and B, the capacitance is connected. The capacitance is connected in between Y and B, which is minus J10. It was given as minus J10. So in between R and Y, so the R plus Jx is connected. R plus Jx is connected. Now what we need to find? So we need to find the R and X values. R and X values. So let me take this as IR and this IY. This current is IY and this current will be IB. Right? So this is like Y point. Now, so it is VRY and it is VY. Right? So it is VBR. So it is VBR. So now the problem statement is like this. We need to find the R and X. So it is very simple problem. So try to solve, try to observe here. So here we need to find, so in a balanced circuit, if I find the IN or if I add the three currents, so it will be 0. So that is IR plus IY plus IB should be equal to 0. IR plus IY plus IB should be equal to 0. So IY is already given, it was given as 0. It was mentioned in the problem. So it is IR equal to minus IB. So the current IR equal to minus IB. So how you can find the IR? So VRY is applied across the R plus JX. So that is, if I take the line voltage as a reference here, so which voltage we are taking the reference, that matters actually. So for example here, we are taking the line voltage as a reference. So if I take the line voltage as a reference, so it is VR at an angle, VRY at an angle 0 divided by R plus J. And minus IB, so IB is in this direction. So IB will be the VYB by, so VYB is in this direction. So Y is positive, we assume B is negative. So but IB is in this direction. So it will be the minus VBY divided by minus JX. So JX is given as 10 volts, right? So it is VBY. If I write the minus VYB, I can write it as a minus VYB. So as we know that, so minus of minus, it will be plus. So plus VYB divided by minus. Now it is simple. So up to here, if you can apply the concept, it will be simple. So I take the VRY as a reference, so which is equal to, if I represent as a V line voltage, so V line at an angle 0 divided by R plus JX. So VYP. So what is the phase difference between the RY and YB? It is minus 120 degrees. So VL at an angle minus 120 degrees divided by, so minus J10, that is 10 at an angle of minus 90. 10 at an angle of minus 90. So now if I find the R plus JX, so VL and VL will get cancelled out. If I find the R plus JX, so it will be the, so 10 at an angle of minus 90 divided by minus 120, so it is equal to 10 at an angle 30 degrees. So if I expand this one, 10 cos 30 plus J 10 sin 30, so which is equal to 5 root 3. So let me, so which is equal to 5 root 3 plus 5 J5. So from this R equal to 5 root 3 and X equal to 5, right? So now let us see the answer. So option C is the right option. So option C is the right option. So now let us solve the next question. So here, so what is this question? So three identical impedances are there. So that is 10 at an angle minus 15 degrees. They are connected in the star. Now, so we have the three-phase line voltage is given, which is 208 volts. Three-phase line voltage is given, so which is 208 volts. Now we need to find the phase current IA, but what we need to take the reference, so VCA. So in this problem, it was given as line voltage is given as 208 volts, right? So what we need to take the reference, VCA. VCA we need to take the reference. That is 208 at an angle of 0. So VCA we need to take the reference. So what we need to find? IA we need to find. So it is star connected. So impedance per phase is given as 10 at an angle of minus 15. Now you can easily find. So what do you need to find? IA. So IA, how we can find the IA? So VA divided by, that is A phase per phase voltage divided by Z per phase. So you will get the IA value. In a star connected, line current equal phase current. So if I find the phase current, it will be the line current also, right? So now, so we need to find the VA here. How we can find the VA? So observe here. So let me explain the concept so that you will understand easily. First, try to understand the concept. So we have the reference of VCA, and let me represent with the three 120 degrees lines. So here it is the VCA is given. So what is this one now? So if you observe here, how the line voltage should be AB, BC and CA. So AB, BC and CA. Now we take the reference this one. So now in which order it will be the CA, AB and BC. So it is VAB, so it is VAB and it is VBC. Right? Now I want to find the IA phasor angle. So how it will be the, so I need to find the VA phasor first. So where it will be the VA? So as we know that in a star connected system, the line voltage leads the phase voltage by 30 degrees, or the phase voltage lags the line voltage by 30 degrees. So here, so if I draw the VA at an angle 30 degrees and it is lagging, line voltage is leading and phase voltage is lagging. So by 30 degrees. Now what is the angle? It is minus 150 degrees. The angle will be the 150 degrees. So VA is lagging VCA by 150 degrees. So if you know that, that is sufficient. So how we can find the VA? 208 divided by root 3. So 208 divided by root 3. So V phase equal to V line divided by root 3. 208 divided by root 3. So what is the angle between the VA and VCA? So it is minus 150 degrees. Divided by, so what is the impedance? 10 at an angle minus 15. Minus 15 degrees. So if you simplify this, so you will get the 12 at an angle of, so minus 15, so it will be the minus 135. So the answer is B. So let us solve the next question. So it was asked in the previous year question. So yes. So let me explain the question. So what is the question here? So it is a star connected source. So VRN is given as 100 volts. So VRN is given as 100 volts. So VRN is given as 100 volts. And it is star connected source with VRN. Delta connected load we have. So which is equal to Z delta connected load. Per phase value is equal to 8 plus J6. 8 plus J6 ohms per phase. So it is the per phase value, right? So now, then the phase current and line current we need to find. So what is this connection? So the connection is simply, so we have the star connected source and we have the delta connected load, right? Delta connected load. So in this case, so try to use this method, which is very easy. So for example, so we need to connect like this, right? So find the equivalent star value for the delta. So first find the equivalent star value for the delta. So how we can find the equivalent star? So it is Z delta, it is Z star, ZY. So ZY equal to Z delta by 3. Right? So it is 1/3 times of the Z delta. Now if I find the ZY, so what is the value? So 8 plus J6 divided by 3. Now we got the star-star connection. Now star delta connection is converted into the star-star connection. So now if you find the, so this current value, so which is equal to line current. Remember this point? So now we are finding the line current. So in a simplest way, we can represent, so VAN is applying across the ZY. So directly you can use this equivalent circuit model. So which is VAN at an angle 0. So is applying across ZY. Is applying across the Z. So now simply one phase we have separated. But what is this current? So this current is line current. In case of star connected source, the phase current equal line current. So it is line current. Now find the line current. So how you can find the line current? So how you can find the line current from this? So VAN value is the 100. VAN value is the 100 volts. So 100 volts is the VAN value. So Z star will be the 8 plus J6 by 3. Find here. So line current. So what is the line current? So the line current equal to 100 divided by 8 plus j6 by 3, which is equal to 100 into 3 divided by 8 plus j6. So what is 8 plus j6? So 10 at an angle of 36.86. So square root of 8 square plus 6 square equal to 10. So from that 10 by 8 by 10, you can get the cos theta. So which is equal to 0.8 is the cos theta. So theta will be 36.86. So 300 divided by 10 at an angle of 36.86. Right? So it will be the 30 minus 30 at an angle of minus 36.8. So what is the line current now? The line current equal to 30 amps. So in case of star connected source, so in case of delta connected load, now we got this current. Now if I want to find the phase current, so how I can find the phase current? The phase current will be the line current divided by root 3 in case of delta connected load. So line current divided by root 3, so that is 30 divided by root 3, so which is equal to 10 root 3. So 10 root 3 and 30 is the answer. 10 root 3 and 30 is the answer. 10 root 3 and 30. So it is the answer. Option B is the right option. Now let us solve the next question. So here the question will be like this. So what is the question? So VAN is given, VBN is given, VCN is given. So we need to find the R value. We need to find the R value. So already we have given us the zero current in the neutral band. So it is a balanced star connected load, star connected supply. So now, so here let us find IR plus IY plus IB equal to 0. So the neutral current equal to 0. So IR, which implies IR plus IY plus IB equal to 0. IR plus IY plus IB equal to 0. So VAN is given as 100 at an angle 0. So how can we find the IR value? So VAN divided by R. So VAN divided by R is the IR value. So let me represent it as a directly so value. So 100 at an angle 0 divided by R. So what is the IY? So what is the IY value? So IY is given as, so IY is given as, so it is represented with the ABC. So let me use the same analogy. So ABC, IA plus IB plus IC equal to 0. Right? So from this, it is VAN by R. It is VBN divided by, so VBN divided by Z10 and VCN divided by minus Z10. So which is equal to 0. Now find VAN. So already VAN, VBN and VCN values was given. So what is the VAN? So 100 at an angle 0. So 100 at an angle 0 divided by R plus, so what is the VBN? So 100 at an angle of minus 120 divided by 10 at an angle of 90 degrees, right? So and then VCN is given as, so 100 at an angle of minus 120 plus 120 divided by minus Z10. So 10 at an angle minus 90. So which is equal to 0. Which is equal to 0. Now we need to find R value from here. R value from here. So very easy if you know the basic concepts. So here it will be the, so 100 at an angle of 0, 100 by R, so which is equal to, if I move this side, so minus of 100 by 10, which is equal to 10, So 10 at an angle of minus 210 degrees, So 10 at an angle of plus 210 degrees. 10 at an angle of plus 210 degrees. Now we got this value. So it is minus of. So it is, if I take the 10 as separate, so how you can find this? So if you know the fast calculations, you can find. Otherwise, you can find in a simplest way. So there is a two values. If I take one as a reference, so it is one at an angle minus 210 and one at an angle 210. So it is 210 will be like this. For example, if the axis is like this, so where is 210? So one at an angle 210, plus 210, and one at an angle minus 210, it is 180 plus 30. So one at an angle minus 210, and it will be the one at an angle plus 210. Right? So there is two phasors are there. One at an angle of plus 210. In this direction it is plus. So in this direction it is, in the anti-clockwise direction it is minus. Now we need to find the resultant. If I add both, so it will be like this. So it is on 180 degrees phase. 180 degrees. So if we consider it is at 0 degrees, it is 180 degrees. So root 3 at an angle of 180 degrees. So directly you can find. So it is, if the 10 also get cancelled out, so it will be the 10 by r equal to, so minus of root 3 at an angle of 180 degrees. So what is the root 3 at an angle of 180 degrees? So it is equal to minus, so minus root 3. Minus of minus, it will be the plus root 3. So r equal to 10 by root 3. R equal to 10 by root 3. So this is how you can find. So r equal to 10 by root 3. So the value of r equal to, so 10 by root 3. So let us solve the next question. So how can we solve this question? See here. So using the Thevenin's equivalent circuit, so determine the RMS value of the voltage across the 100 ohms. So we need to find the RMS value of the voltage across 100 ohms. So using the Thevenin's equivalent circuit. So how we can find the, so by using Thevenin's equivalent circuit, so here, so to find the Thevenin's voltage, so we need to open this one and we need to find, right? So VTH we need to find first, that is Thevenin's voltage. How we can find? So we need to, that is open circuit voltage, we need to open the load and find the voltage across this. So what is the voltage? So VAN is directly applying across this. VAN is directly applying across. What is that voltage? VAN. So already it was given as 400 by root 3. So it is VTH is the 400 divided by root 3. 400 divided by root 3. Now, what we need to find? So we need to find R Thevenins. So how we can find the R Thevenins? To find the R Thevenins, we need to short circuit the sources. So we need to short circuit the sources. And this should be in the open condition. So we need to find RTH from this. How you can find? So RTH is equal to, so these two are shorted. So now these two are in the parallel condition. So if we expand this, so the 300 in parallel with the, so 300 and 300. So RTH equal to so 300 in parallel with parallel combination of 300 and 300. So which is equal to 300 in parallel with 150, so which is equal to 100. So that is 300 into 150 divided by 300 plus 150, this which is equal to 100 ohms. Now let us draw the Thevenin's equivalent circuit. We have the Thevenin's voltage, so which is 400 by root 3. We have the Thevenin's voltage, which is 400 by root 3. Right? So we have the impedance, that is value of the impedance will be, so 100 ohms. RTH is 100 ohms. Now we need to find the voltage across the 100 ohms. So voltage across 100 ohms. Right? So now if you observe here, it will be the 400 by root 3 is divided into two equal voltages, so which is equal to 200 by root 3. So this value, voltage across 100 ohms is equal to 200 divided by root 3. Right? Simple. So the total voltage is 400 two equal resistors are series, so they will distribute, the voltage will distribute equally, so it will be the 200 by root 3. So answer will be the 200 by root 3. Answer will be the 200 by root 3. So now let us solve the next question. So here, a balanced delta connected load has an impedance of 9 at an angle 30 degrees. So the balanced delta connected load has impedance of load angle at an angle of 9 at an angle 30 degrees. So we need to find the equivalent of star. Z star we need to find. So how we can find? So as we know that Z star equal to 1/3 of Z delta. So that Zy equal to 1/3 of Z delta. So from this you can find, so which is equal to 9 at an angle 30 divided by 3. So which is equal to 3 at an angle 30 degrees. Right? If the impedances are connected in delta, so if you make it as the equivalent circuit, so what happens? So the equivalent circuit star value will be Z delta divided by 3. So it will be the 1/3 of the Z delta. So answer will be the 3 at an angle 30 degrees. Now let us solve the next question. So here a balanced 5 plus J4 is connected in delta. So already it was given as Z delta is given as 5 plus J4. Now we need to find the equivalent star connection. The same problem. So it will be the Zy equal to 1/3 of Z delta. So 5 by 3 plus 4 by 3. So which is equal to 1.666 plus J 1.3. 5 plus J4 divided by 3. So now we got the 1.66 plus J 1.3. So let us solve the next question. So which is conceptual question. So what is this question? So let me read for you. A balanced three-phase circuit is energized by the three-phase sinusoidal voltage source, right? So a three-phase sinusoidal voltage source is given to the balanced load. Now it is the balanced or symmetrical source. Now if you want to find the steady state three-phase instantaneous power, so here, so let me explain the concept so that you can understand. Let me explain the concept. So here, so we have the three-phase. We need to find the three-phase instantaneous power, which is very important. So which is very important, three-phase instantaneous power. So which is equal to P of T equal to, so VA into IA, VB into IB, and VC into IC. So now, if I find the P of T, for example, if I take the VA as sine at an angle 0, so VB as sine at an angle of sine of minus 120 degrees and VC sine plus 120 degrees. If I take all the voltage and current, if I multiply all the things, so I will get, even it is instantaneous, I will get the 3 into V into I into cos pi. Where pi is the angle between the phase voltage and phase current. If it is a three-phase instantaneous power, it will be like this. For example, if it is a single-phase instantaneous power, so we have derived for the single-phase instantaneous power also. So for example, if it is single-phase instantaneous power, how the voltage will be? So how the power will be? So here it will be the VI cos pi into 1 minus cos 2 omega t plus VI sin pi, minus VI sin pi into sin 2 omega t. So this is the expression for single phase. So what is the difference between these two? If you observe in the single phase, either active power or the reactive power. So what is the frequency here? So it is 2 omega t, double the fundamental frequency. They are oscillating with the double the fundamental frequency. But if you take the three-phase power, So the instantaneous power is constant. So which is advantage for the 3-phase 4. The instantaneous power is constant. So there is oscillations. If you connect the same power to the single phase motor, so the torque will be oscillating. In case of 3-phase, the torque will be constant torque. So here it is instantaneous power is independent of time. In case of 3-phase, the instantaneous power is independent of time. It is not dependent on time. So it is constant. So here, so which option is correct? So here the first option is double the sinusoidal frequency. It is not correct. So second option is it varies with the fundamental frequency. It is also not correct. So it is varies with the twice the fundamental frequency. So it is also not correct. So the fourth option is correct. It is independent of time and remains constant. So which is very important. So basically it is an interview question which is very important. Now let us see this one. So here three identical impedances are connected. First they are connected in the star and then they are connected in the delta. So let me explain this. So here, so let me explain this problem. So here three resistances are there, three impedances are there. First they are connected in the star. So first they have connected in the star. Connection. So I will represent impedance in this type. So here, so they are connected in the star connection. Let me call this as a R. They are connected in the star connection. How we can find in the star connection the power? How we can find? So 3 into V phase square divided by R. V phase square divided by R for the each phase power. If I multiply with the 3, I will get the 3 phase power. So power I can calculate like this. So if I want to represent in the line voltage format. So what is the line voltage phase voltage relation in the star connected system? So the line voltage is equal to root 3 times of the phase voltage. So for example, if I want to find the phase voltage, so I can represent as a 3 into VL by root 3 whole divided by R. So which is equal to VL square divided by R or VL square divided by Z. So what is the power in the star connected? So which is equal to VL square divided by R. So which is very important. So now let us take the delta connection. If I take the delta connection, so how it will be? So if I take the delta connection, take the R, and R. So here it will be the line voltage equal to phase voltage. So it will be the power equal to, in case of delta connected, power equal to 3 times of the VL square divided by R. Here the line voltage equal to phase voltage in case of delta. Now if I want to find the relation, so it is VL square by R, it is star connected power. If the same resistance are formed with the delta, the power will be the 3 VL square by R. So which is equal to 3 times of the power in the star. Delta connected power equal to 3 times of the star. So now which option is correct option? So option D is the right option. Right? So now let us solve the next one. So it was the same question and it was asked in the ESC 2004. So initially they have connected the load. So initially they are connected in the star. Now they are connected in the star. Initially they are connected in the star, P star. So which is equal to P watts. And then the same load is connected in delta with the same supply. Now what is the power? We need to find the P delta. So same problems. P delta equal to 3 times of the P star. Right? So now what is the P star here? It is the P. It is 3P. 3P watts. Right? So initially they are connected in the star, so it will be the 3P watts. Right. So initially they are connected in the star, it will be the 3P watts. Now, let us solve the next question. Here it is. Here it is. So if you observe here, a balanced three-phase three-wire supply feeds balanced star connected resistor. If one of the resistor is disconnected, what is the reduction in the percentage of load? We need to find the percentage of load. It was asked in the civil service examination. Now, so here the three resistances are there. As we know that, so if it is a star connected, if it is a star connected, if it is a star connected, what is the power here? What is the load power? So load power equal to PL square divided by R. PL square divided by R. Now, what happens if one of the resistor or one of the load has removed now? One of the load has removed now. So what happens if one of the resistor has removed? So here it will be like this, right? So now if one of the resistance has removed, so the line voltage will be like this. So it is R and R. If I find the power, so what is the power here? It is the line voltage, right? So here it is VRY, VYB and VBR, line voltage. So what is the power in this circuit? So power equal to the resistances are now they are connected in series. So power equal to, so power in the open star connection. So power in the open star connection, for example, I will represent like this. Power in the open star connection. So it will be VL square divided by 2R. 2R. So now how much is the reduction? It is VL square by R. It is VL square by 2R. How much is the reduction? So it will be the 50%. So P equal to, so which is equal to P star divided by 2. P open star equal to P star divided by 2. So the reduction in the power equal to 50%. So answer is 50%. Answer is 50%. So these three options are the wrong options. So option is the 50%. So now let us solve the next question. So what is the question here? So a star connected resistive load and a delta connected pure inductive load. So a star connected resistive load is there. So in parallel with delta connected pure inductive load will be there. So here the voltage is, the input is the star connected input, star connected source, so which is equal to 1000 root 3. So here the source voltage is given as 1000 root 3. 1000 root 3. So now each resistance value is 100 ohms. So each arm inductive load value is XL is 300 ohms. Now easily, let us find easily. So here we have the star connected resistive load, right? So each value of the resistance is given as 100 ohms. Each value of the resistance is given as 100 ohms. So the inductive load is there, which is connected in the delta, So it is given as J 300 ohms. So these two are connected in the parallel. J 300 ohms. These two are connected in the parallel. So how we can simplify this one? So we can easily simplify. So because now the source is connected to the star connected source. Source is the star connected source. So now if I convert this, these two are connected in the parallel. So for example, if I convert this delta into star, so these two will be in the parallel. So each phase will get into the parallel. So for example, if I find the star equivalent of this one, so how I can find the star equivalent? So star equivalent equal to Z star equivalent equal to, so Z delta divided by 3. So which is equal to J 300 divided by 3. So which is equal to J 100 ohms. Now, so let me draw the circuit now. So you can find easily. Let me draw the circuit. So here, if you observe here, so the circuit will be like this. RYB we have. So now, so the load will be like this: 100 ohms resistance and J 100 ohms inductance are connected in the parallel. So 100 ohms resistance, so J 100 ohms are connected in the parallel. Right? Now 100 ohms resistance and the J 100 ohms are connected in the parallel. Right? So now it is V, so it's R, Y, and P. So now, if I want to find the total current supplied by the source, that is line current equal to phase current here, line current equal to phase current here. So I need to find the phase voltage here. So I need to find the phase voltage here. So that is VRN I need to find. VRN I need to find. So if I find the VRN, so if I apply across this one, I will get the two currents. So I1 and I2. If I add both, I will get the total current, IR. So where IR equal to I1 plus I2. So how the I1 can be found? VRN divided by 100 ohms. So what is the VRN? So it is given as 1000 root 3. So 1000 root 3 divided by, so it was given as 1000 root 3. So it is 1000 root 3 divided by 1000 root 3 divided by root 3. So it is 1000. So 1000 by 100, 1000 at an angle 0 divided by 100 ohms plus 1000 at an angle of 0 divided by 100 at an angle of 90 degrees. So inductive load, right? So inductive load. So J100 is the 100 at an angle of 90 degrees. So 100 will be cancelled out. So which is equal to 10 minus J10. 10 minus J10. So if I find the IR magnitude, so which is equal to 10. So the answer will be the option. So now let us solve the next question. So now let us solve this question. So here, a three-phase star connected operating with the power factor angle pi. The power factor angle is given as pi. So which is the angle between the phase voltage and phase current. So option B is the right option. Right? Now let us solve the next question. So what is the power absorbed by the three-phase load? So if you take the three-phase load, the power absorbed by the three-phase load will be, so which is equal to P equal to root 3 into VL IL cos phi. Right? So where VL in case of star connected load, so VL equal to root 3 into V phase. In case of delta connected load, so IL equal to root 3 into I phase. Right? So now option B is the right option. So now let us solve the next question. So here, so a balanced delta connected load has given 16 plus J12 ohms and it is connected to the 230 volt supply. Only you need to find the line current and phase current. So in case of delta connected load and the delta connected source, so what is the line voltage equal to phase voltage? So VL equal to V phase equal to 230. Right. So now it was given as delta connected load, it will be the 16 plus J12. Now let us find the phase current first. So how you can find the phase current? So phase voltage divided by impedance. So what is the phase voltage? 230 volts. What is the impedance? It is 16 plus J12. 16 plus J12. How we can represent this one? So which is equal to 230 divided by 16 plus J12 is the square root of 16 square plus 12 square will be the 20. So at an angle of 20 by 16 by 20, it is 0.8, which is nothing but 36.8. Right? So which is the magnitude will be, phase magnitude will be, so 230 by 20. And the angle will be minus 36.86. And if you find the cos phi from that, it will be the 0.8. Right? 0.8. Now it will be the 230 by 20. We need to find the line current. So how we can find the line current? So the line current equal to, so 230 by 20, which is equal to 11.5 amperes into root 3. So that is phase current into root 3. So you will get the 19.9 amperes. Now we need to find the real power drawn. So how you can find the real power drawn? So which is equal to root 3 into VL into IL into cos phi. So P equal to root 3 into VL into IL into cos phi. So what is the VL? So VL equal to 230 volts. So that is equal to root 3 into 230 into, right? So what is the IL? We got 19.9 into cos phi. So what is the cos phi? Cos phi is the 0.8. So from this you can get the 6.34 kilowatt, 6.342 kilowatts. So option C is the right option, right? So now let us solve the next question. So a three-phase power three-phase supply feeding the star connected load. So three equal resistance. If one of the resistance has removed in a star connected load, if one of the resistance is removed, it is an open star connection. So what is the reduction of the power when compared to the original power? So there are two conditions are given. Already we have derived this one. So star connection and the second connection is the open star connection. So what is the power in this? We have derived. So which is equal to VL square by R. So what is the power in this? So it will be the VL square by 2R. So it was reduced by the 50%. So answer is the 50% of original power. Right? So now let us solve the next question. So here it was given as two resistors are equal value of the resistance connected in series. Lines B and C, a three-phase symmetrical 400 volts system. So it is a 400 volt system. It is given as 400 volt system and it is VAB. What is the magnitude of voltage between the line A and junction ref resistance? So here the two series resistors are connected in parallel with the B and C. So in parallel with the B and C, two similar resistances are connected. So we have the common point N. Let us assume that common point N. So they are asking to find out in between the A phase, A line and the N point. We need to find the VAN. How we can find the VAN? So if I take the VAB as a reference, so VAN equal to VAB plus so VBC divided by 2. So what is VAB? VAB is already given, which is equal to 400 at an angle 0 plus, so VBC divided by 2. What is the VBC value? So VBC is 400 at an angle of minus 120 divided by 2. So it is 200 at an angle of minus 1. So if I substitute in this, it will be the 400 plus. So 400 plus 200 at an angle of minus 120. So 1 at an angle minus 120 is like, it is A square. Right? A square operator. A is the 1 at an angle 120 and B, A square is the 1 at an angle of minus 120. So it is minus 0.5 plus j 0.86 or root 3 by 2 j root 3 by 2. So if I substitute in this, so it will be the minus 100 plus, so minus 100 plus j 100 root 3. Now let us simplify this one. So VAN equal to 400 minus 100 is 300. So 300 plus j 100 root 3. Now we need to find the magnitude of this one. So how can we find the magnitude? So let us find the magnitude. Because calculator is not allowed, try to find out by yourself. So 300 square plus 100 root 3 square. So if you take 100 as common, so it will be the 100 square root of 3 square plus 9 plus 3, 12. So which is equal to 2 into 4 into 3. So 2 will get out, it will be the 200 root. So 200 root 3 ohms. So now it will be the 200 root 3 ohms. 200 root 3 ohms. Very simple. Just try to understand the concept. It is very simple problems. Next. So now let us find the IR is IY is IB. So there is a connection like this. So in this we need to find IR is IY is IB. So let us find here. So for example, let us find the IR first. So what is IR? In that case, what is IR? So VRB divided by R1. VRB divided by R. If I take the VRY as a reference, so which is equal to VL at an angle 0. For example, VRY as a reference. So VYB is, how much VYB? VYB is VRY at an angle of -1. VBR equal to VRY at an angle of +1. So +1. So now we need to find it is equal to minus VBR. So we can call this as a minus VBR divided by R. So from this it was minus 1 at an angle of -120. 1 at an angle of -120 divided by R. So if you find the magnitude, it will be the 1. So the magnitude will be 1. So you can write this as a 1 at an angle of -60. So VRB is the +120, right? -60 divided by R. 1 at an angle of -60 divided by R. So here, so it will be like this. Now find the IY. So how can we find the IY? So IY is in this direction, VYB divided by R1. VYB divided by R1. So what is VYB? So VRY at an angle of -120. So VRY. So it is, let me represent as a VL. So all the terms as VL. So VL at an angle of -120 divided by R. So it is, now find the IB. IB equal to minus of IR plus IB. Minus of IR plus IB. So if I add both the things, so what is the output voltage? So if I add IR plus IB, so IR equal to minus VBR by R. So minus VBR equal to VL at an angle of 120, that is minus A. So we need to find the A square. So A square minus A. So if you observe here, A operator, if 1 I taken as a reference, so A will be in this direction, so A square will be in this direction, right? So A at an angle 120 degrees. So for example, I want to find the A square minus A. So A square minus A will be in this direction now. If I find the A square minus A, it will be here. So it will be the root 3. Root 3 at an angle of 90 degrees. Root 3 at an angle of, so it is minus 90 degrees. So I got it is minus of root 3 at an angle of 90 degrees. Minus 90 degrees. So if I find the magnitude of this one, so I will get the root. So now if 1 is, so root 3 into VL by R. So if I find the magnitude of this one, so I will get the VL by R1. If I get the magnitude of this one, it will be the VL by R1. So it is a root 3 into VL by R1. So it is equal to 1 is root 3. So option A is the right option. So very simple, 1 is 3. It will be the 1 is root 3. So the answer will be the E. So now let us find the next question. So now let us answer the next question. So here, so it was given as unbalanced load. So now it was given as unbalanced load. So it is given as unbalanced load. And whatever be the power consumed by this unbalanced load, so which is equivalent to the star connected load which consists of the Rx resistor. Now, so if you observe in this, so these two are the inductance capacitance, and if you find power across this inductance capacitance, it will be 0. So the power will be the 400 square. The total power will be the 400 square divided by 100. 400 square divided by 100. In case of star connection, for example, if you have the star connection here, Rx here. So if I convert this star connection Rx, for example, if I convert into delta, this Rx will be 3 times. If I convert into equivalent delta, this Rx will be 3 times. 3 into Rx. Now, if I find the power equal to, power across Rx equal to total power equal to, if I find the power, so power across Rx equal to 400 square divided by 3 into Rx. 3 into Rx. If I find the total power also, so it will be the into 3 into Rx. So now 400 square and 400 square will be cancelled out. So it will be the Rx equal to 100. Rx equal to 100. So thank you so much. Thanks for attending the session.